Now we will see the same program which we discussed in last lecture with by using a new instruction. So there is an instruction loop. So as I already told you, 8086 processor has a very powerful set of instruction set. So now what will happen in loop instruction? Loop instruction can replace these two instructions, DEC CX and jump no zero repeat. So these two instructions can be replaced by loop. Now with loop instruction, what happened in loop instruction, here I will explain. Suppose there are few set of instructions we have written. Let us assume instruction number 1, 2, 3, 4, 5 like this. And here we have written loop, right? And after that also there are many instructions. So this is instruction number loop we have written at as a sixth instruction. Then instruction number 7, 8, 9. Again there are many instructions. Now with the loop instruction we have to use one label. So here suppose I have written loop repeat. Okay. So loop repeat, and this repeat label I have written in front of instruction number 2. Repeat. Now what will happen? This loop instruction, it will decrease the value of CX register by 1. And if the CX is not 0, then it will transfer the sequence of program to the label, to that instruction where we have written this label, right? So here we have written label repeat, and repeat label is here. So when the microprocessor will execute loop instruction, what it will do? It will do two things. First, decrease the value of CX by 1. Then, if CX is not equal to 0, then go to label. Then sequence of program will go to label. Wherever we have written label, sequence of program will go here. And now these set of instructions will again execute it. And now when the loop will execute it, then again it will reduce the value of CX by 1. And still if CX is not 0, again it will go to the label repeat. So this means by these set of instructions will be executed CX number of times. If in CX, suppose we have stored in CX 2, then first time these set of instructions will be executed. Now loop will reduce the value of CX by 1. CX is now reduced from 2 to 1. It is not 0. Again the sequence of program will go to here. Again now these set of instructions will be executed. So this is the second time these set of instructions are executed. Now loop will again reduce the value of CX by 1. So now previously CX was 1. So now it will be reduced to 0. Now once it is 0, then program sequence will not go to the label repeat. Controller will execute next instruction written after loop. So these set of instructions in this case repeated 2 times, right? But always remember, loop instruction will reduce the value of CX only, right? Not AX, not BX, not DX. So CX is a general purpose register, as we already know. General purpose registers are AX, BX, CX, DX. But CX is having a special function. right? And the function is it acts as counter in case of loop instruction, right? So it always, loop instruction always reduce the value of Cx only, right? So whenever you are using loop instruction, then always use Cx register as counter, right? So basically what loop instruction is doing, it is decreasing the value of Cx by 1, and if the value of Cx is not 0, then it is going to the label, whatever label we have written. So this means here two instructions with DEC-Cx, we are decreasing the value of Cx by 1, and by J and Z instruction we are checking whether the value of Cx is 0 or not. So these two set of instructions can be replaced by loop. So here we can remove these instructions, and here we can write loop repeat, and after this halt. So here these set of instructions will be repeated Cx number of times, and in Cx, since in this example we want to transfer 3 bytes, so in Cx we are having 0003H. So these set of instructions will repeat 3 times, means 3 bytes will be transferred from this place to this place, then this place to this place, and F3 from this place to this place. So this is another approach to write the program. Now there is another instruction by using which we can again reduce the number of instructions in this program, and that instruction is related to string, right? So there are string related instructions. So what is string? If we say string of bytes, means if we store the bytes or 8-bit number in consecutive memory locations, then those bytes are called as string, right? For example, from the offset 1000H, we are having first byte. At next offset 1001H, we are having second byte. At 1002H, we are having third byte. So these data which are from location offset address 1000H, in the consecutive location we have stored the bytes. So this is a string of byte, right? So there can be 100 bytes in the string, there can be 10 bytes in the string, right? So if there are 10 bytes in the string, then 10 bytes are stored in consecutive memory location. And there can be a string of words, right? We know that a 16-bit number is called as word. So a string of word at location 1000 and 1000H. Here we are having first word, right? Always remember, suppose this is a 16-bit number 3279, right? One word. So if we want to store these numbers in the memory, then Intel use the convention of storing lower byte at lower offset address and higher byte at higher offset address, right? So suppose this is the number. So this number will require 2 memory locations to store, because at one location we can store only 8-bit number. So here at 1000H offset we will store lower byte. that is 79H. At higher offset address 1001, we will store higher byte, that is 32H. So first word we have stored here. Second word, for second word we require two memory locations, 1000, 1002 and 1003. So at these two locations we will store second word. And third word again require two memory locations, so 1004H to 1005H. So at these two locations we will store third word, right? So again here the words we have stored in consecutive memory locations. So this is a string of words. So we are having a string related instruction in 8086 microprocessor, and the one instruction is move SB, right? Move string, S for string, B for byte. Another instruction is move string word, right? So there are two instructions related to the move operation, and these are move string byte and move string word. So this instruction is used to move the string of bytes from one location to another location. This instruction move SW is used to move the string of words from one memory location to another memory location. So we will just use the same program where we want to transfer these 3 bytes. So we are having a string of 3 bytes. So first byte is at offset 1000H, second byte at offset 1001H, and third byte is at offset 1002H. So these are the string of bytes, and we want to move this string of byte from these 3 locations to new 3 locations. So in this case, I will use instruction move string byte, right? So in case of move string byte, what will happen? This instruction will move 1 byte of data from data segment offset. Offset address is given by SI, right? From this address, it will transfer the 1 byte to extra segment DI, right? So from this memory location, 1 byte will be transferred to this memory location. Now after transferring this 1 byte, when we discussed about the flags, at that time I told you there is a flag called as direction flag. So there is a flag called as direction flag. If you remember this direction flag in the flag register, if this is your flag register, then first 8 location bits 0 to 7 are used for status flag. After this, bit number 8, 9 and 10. At bit number 10, we have direction flag, right? So this direction flag if direction flag is 0, then our processor operates in auto increment mode, right? The meaning of this auto increment, so this direction flag basically is used with string instructions, right? Like move string byte or move string word. So if we will make the direction flag 0, then what will happen? One byte will be transferred from DS:SI memory location to ES:DI memory location, and after transferring of one byte, the value of SI will be increased by 1 and the value of DI will be increased by 1. Right? So if the direction flag is 0, then value of SI and DI will be increased by 1. If we make direction flag 1, then if we are using move string byte instruction, then 1 means auto decrement mode. So after transferring one byte from this memory location to this memory location, the SI value will be decreased by 1 and DI value will be decreased by 1. So this is the concept here. So with this concept, we will use now move string byte instruction to perform this operation, right? So here we will write first initialization instruction, move AX, 2000H. Then move DS, AX. Now ultimately we know that we are going to use this instruction move string byte. And we know that in case of move string byte, data is transferred from DS:SI to ES:DI, right? So first we will load the starting address of our source data, offset address of our source data in SI, right? Just like previous case, move SI, 1000H. And in DI register where we want to transfer our data, the starting at offset address of our first destination, we will load in DI. Move DI, 1010H. Now here in this particular case, we are moving the data from the data segment whose which is initialized by 2000H, right? So we are moving the data from data segment and into data segment only. In actual, we are not moving the data from, because we know that in our this is our data segment, and let us assume this section of the memory is our extra segment, right? So basically here we are not transferring our data from data segment to extra segment. We are transferring our data only from data segment into data segment only. But when we use string instruction, at that time where exactly we are transferring our data, right? That physical address will be calculated by using ES register, extra segment register, right? So here the segment address will be same as the data segment, but we have to initialize that ES register also. So for that, what we will do, move ES, AX. Same this. Whatever is the value of DS, same we have stored in ES, right? So now the value of ES is also 2000H and value of DS is also 2000H, right? Now after this, move CX, 0003H. How many bytes we want to transfer? With that we will initialize the counter. Now what I will do, I will make the direction flag 0. By default its value is 0 when we reset our microprocessor, but we shall not take any chance. With the instruction we will make it 0. So there is an instruction which can make a single bit 0, and that instruction is CL, right? Clear. So with this instruction, if I write CLD, so this D indicates direction flag. So CLD instruction will make one bit of flag register, that is direction flag bit 0. If you want to make that bit 1, for that there is an instruction ST, right? ST means set, and with this we write D. Then with STD it will make the direction flag bit set, right? So we will use the auto increment mode. That's why I will use instruction here CLD. With this, all these instructions are initialization instruction. We have initialized the things. Now after this instruction, we have written move string byte. And with this instruction, I will use one prefix, that is REP, right? Repeat. This prefix is repeat. So the purpose of this prefix is that instruction in front of which we have written REP, that instruction will repeat CX number of times, right? So now here what will happen? This repeat prefix we have written in front of move string byte. So now this instruction will run CX number of times, right? Once this instruction will be executed, CX will be reduced by 1. Again this instruction will be executed, again CX will be reduced by 1. So this instruction will execute now CX number of times, and in CX we have stored 3. That's why now move string byte instruction will execute 3 times. So now what will happen? When the first, now in DS we have 2000H, and in SI we have 1000H. In ES we have 2000H, in DI we have 1010H. In CX we have 0003H. Right? Now you see what will happen. When move string byte instruction is executed first time, then what it will do? It will transfer 1 byte of data from the physical address calculated by DS and SI. Right? So from that physical address, it will transfer 1 byte to the destination whose address is calculated by ES and DI. Right? So here in this case, since ES is also 2000, that's why the physical address generated will be for this location only, right? So now the first byte will be transferred, that is 39 will be transferred when move string byte instruction executed first time. After the transfer, since the direction flag is 0, that's why automatically SI will be increased by 1. So now SI will become 1001. DI will be increased by 1. It will become 1011. And CX will decreased by 1. And CX will become 2. Right? So these first task, second, see what move string byte will do. First it will transfer this byte to this place, first operation. Second, it will increase the value of SI by 1, second operation. It will increase the DI by 1, third operation. It will decrease the value of CX by 2, fourth operation. So move string byte will perform 4 operations. Now once all these 4 operations has been performed, now again in front of move string byte we have written REP. So what will happen? Since CX is not 0, again move string byte instruction will be executed. Now data will be transferred from data segment this and SI 1001. From this offset, data will be transferred to ES:1011. So basically data 9A will be transferred to this offset address 9AH. After transferring the data, SI will again increase by 1. So now it will become 1002. Di will be increased by 1, it will become 1012. And Cx will decrease by 1 and it will become 1. Now again Cx is not 0. So now this due to repeat prefix, again move string byte instruction will be executed. And now data will be transferred from 2000 colon 1002, means this data, it will be transferred to 2000 colon 1012, means here F3H. Now third byte has been transferred. After transfer, SI will be increased by 1, it will become 1003. DI will be increased by 1, it will become 1013. Now CX will reduce by 1, it will become 0. The moment it will become 0, this instruction will not repeat. Now program will come out from this loop, and here in the last we have written HLT. Program will stop. So in this way, only by using move string byte instruction we can transfer all these 3 bytes. If we have made the direction flag 1, suppose we have written instruction STD, right? If direction flag is 1, so it operates now in auto decrement mode. So now what we will do, everything will remain same. Only in SI, now I will store the highest, the offset address of my that data which has highest offset address, right? That is 1002, and the highest offset of my destination, that I will load here. Now 1012. Everything is same. STD is here. Now what will happen? Move string byte. Now see, DS is 2000, SI is 1002, right? And 1002, and DI is 1012H, and CX is equal to 0003H. So now move string byte instruction, it will transfer the data from 2000 colon 1002 to 2000 colon 1012. Means from here, first this data will be transferred now. First highest byte F3 will be transferred, right? After transferring first byte, now SI will be decreased by 1, right? Because it is now auto decrement mode. So it will become 1001. DI will be decreased by 1. So 1011, and CX will decrease by 1. CX is always decreased by 1. Now CX is not 0, so due to repeat, again this instruction will be executed. Now the data from 2000 colon 1001, means this data. This data will be transferred to 2000 colon 1011. 1011 is this offset. Is now second byte will be transferred. After this, SI will be decreased by 1, it will become 1000. DI will also decrease by 1, it will become 1010. And CX will decrease by 1, it will become 0001. Again CX is not 0, so again move string byte will be executed. Now data will be transferred from 2000 colon 1000, means this is 1000 offset, means this data. 39H, this data will be moved to 2000 colon 1011, 1010. This is the offset 1010. So here this number will come, and after transferring this data, this SI will be decreased by 1, right? DI will be decreased by 1, and CX will be decreased by 1. So CX will become 0. Now the moment CX will become 0, program will come out from the loop and halt instruction will be executed and program will stop. So in this way we can use move string byte, and same way you can, if you want to transfer the word 16-bit numbers, right? Then in place of move string byte we can use move string word. And while execution of the move string word, after transferring one word, SI and DI will be increased by 2 in case of auto increment mode, or it is decreased by 2 in case of auto decrement mode. Because once the one word is transferred, the next word will be after 2 memory locations only. That's why in case of move string byte, with 2 SI and DI will be increased or decreased. Remaining things will remain same.